Here I would like to discuss a few things, a few commands and useful stuff you should know when programming with Matlab or Octave. So just let's get started with some constants. When you start with a blank screen, command window here, there's nothing in it, and you type in pi, it actually displays the pi 3.1416. So that's a preset constant, and there are a few other constants preset in Matlab or Octave. The other one you should always know, especially as you quite often, at least I quite often use it as an index in a loop, is I. That is actually a strange answer. I gives 0 plus 1.0 I. That's the imaginary constant, the square root of -1. So that's useful when calculating in with complex numbers. However, it might create some problems when using I without having preset the whole thing in, for instance, in a while loop. Similarly, J gives the same. So that's just a different notation, quite often used in engineering for this complex unity, the letter J rather than using I. For some strange reasons, the Euler number E is not predefined in Matlab. So there's nothing when typing in E. So the Euler number you actually get when looking at exp1. And then it returns 2.783. So that's a good start, and I guess that's the constant you should know about. You should be aware how to write a number in scientific notation. For instance, if you would like to write the number 4.6 times 10 to the power of -5, then you could write, okay, you multiply 4.8 times 10 to the power of -5. The answer, I'll just store that in a constant, in a variable. The answer actually displays this number in scientific notation. So it's 4.8 E minus 0.5. So be aware that this first definition here, it's more calculation. Take the number 4.8, multiply that with another number that has been calculated to be 10 to the -5. So that's more a calculation of not a definition. So you can define a number with this scientific notation. You might already have wondered how many decimal numbers are displayed. You can actually change that with the format. For instance, here A is pi -3, and just 4 numbers are displayed after the dot. And you can change that by format long, comma, A, and then more digits are displayed. So be aware that the calculation is used might be used with a different precision than the display of the numbers. Let's come back to some other useful stuff. For instance, rounding numbers. There are a couple of useful commands. One is round, not surprising, and displayed here is how to use it. Round A. A has been defined in this way, then it just rounds to the next integer. You can also round to the lower integer or to the higher integer by using floor or ceiling. Likewise, you can calculate the modulus of a number. For instance, here m7 divided by 4, the modulus of 7, 4 gives 3. Okay, that's useful stuff. In Matlab there are many comments, and after a while you get to know some, and make sure that you have a number of commands you always need in your mind, that you can make use of it. One other useful thing is that you can create arrays with the same number quite easily. For instance, here is shown that with the command once, 1, 3, a vector is created with 3 columns and 1 row containing just the 1 at all positions. Similarly, with once 3, 3, you get a matrix. Same for zeros, creates a vector on array with zeros, or by modifying that you can, for instance, create a matrix with just the 9 in all positions. Quite often you need to create random numbers, and there's the command rand, 1, creates just one random number between 0 and 1. As for the just discussed commands ones and zeros, you can create random numbers in a matrix by defining how many rows and columns there should be. So all these random numbers are between 0 and 1. If you would like to have a different range, for instance here, between -1 and +1, so you need to subtract 0.5 and multiply by 2. And in this way you can get other random numbers. For instance, you could easily change to get random integer numbers by using this rand command, multiplying it with a number and then rounding. Try that out yourself, whether you get what you want. Quite often you're using always the same commands, and here are a few. Min and max, not surprisingly, give the minimum and maximum of a vector. Let's try that out with an example. Min of this v will give you the number, the actual number, -2. Quite often you would like to know the position, that is the index where this minimum is, and for that the notation is somewhat different. You need to define one variable m with being the minimum, and p, for instance, for position where the minimum is, the index. If you type that in, you will get p being 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the 9th position. Similarly for max, sum will just give one number, 33, the sum of the vector. The cumulative sum is somewhat different. It's calculating the sum. However, in each case, here for instance, taking the 3 at the second position, calculating 3 plus 1 at the third position, 3 plus 1 plus 2, and so on. In the same way, the mean is calculated, or the standard deviation or the variance of V. Quite helpful. In all these cases, you might have forgotten how these commands are named. In this case, try out, for instance, by typing in help min, and you will get some help here, and with these see also some hints how to use and what there is in Matlab. For instance, sort. I haven't mentioned that. That is probably a useful thing. So you can actually sort the vector V, that the elements are lined up in ascending order. With a matrix, it works a bit different. Let's define a matrix and try it out. When calculating the mean of this matrix M, you get three numbers. That is the mean of each column. Sometimes you would rather have the mean of the whole matrix of all elements, and for that you get another command, mean2, that is in 2 dimensions, and by pressing that you actually get the mean value of all elements. Quite helpful. Sometimes you can't remember all the commands, then try to find this stuff. How could you actually get some the name of some commands where you have no idea what's called and whether it's actually there? You could use look for. Look for instance, let's try that out with look for mean. Then it's Matlab is going through all descriptions of the commands and pukes out all the names where this, in this case, mean is actually used. So you end up with quite a few commands. Here it takes a bit longer to actually go through all commands because Matlab is not running on my machine. Rather, it's working and via VPN. Okay, Matlab just takes an awful lot of time to go through all the commands. Okay, that's one thing, and it's always surprising. I just discovered that there's a mean earth something command. Where is it? Just spotted that. Earth radius. Whatever that is, I could press on that and then discover that it's a mean radius of planet Earth. Okay, it's even in Matlab pre-installed. Another useful command is find. When having this vector V again and we press in find, it searches for all elements of the vector that are equal to, let's say, 5. And it will display the position where the element is that is equal to 5. In here you could display or use other logical expressions. For instance, all the elements larger and equal to 5. Quite helpful. In some cases it's needed to know the CPU time, and you can get that by just typing in CPU time. Even more important and more needed is something like a time difference between two commands, either when typing in, more often in a, for instance, a while or for loop. The command is tick tock, and then you get the elapsed time, in this case 2.24 seconds. Quite useful when, for instance, you would like to speed up your program and would like to display how much CPU time is used in what section of the program. There are obviously many more commands, just a few hints. In some cases you would like to know the variables you have used. For instance, let's define A equal 8, B equals 9, and you have forgotten after programming how they are called or what they are. You could always type in just whose and get a list of all the variables, the names, the size, and the size means how many elements there are in these variables, and actually the size, how many bytes are used to store these variables. Okay, that's enough for the moment. I hope you will find these commands and these hints useful and will discover on your own more commands in Matlab or Octave. All the best with your programs.